Welcome to the IoT Semantics tutorial part 2. My name is Maria Poveda from Universidad Politécnica de Madrid, and I will guide you through the main ontology development activities and related tools during this session. In the last decades, there has been a number of methodologies for building ontologies. In the slide, you can see in purple the traditional or heavyweight ontology development methodologies, and in white, lightweight ones. Such methodologies have been built for different purposes and considering different technologies, even before the definition of semantic web technologies, and RDF and OWL. However, there are some core aspects that can be reused in today's ontology developments. For example, the competency question techniques defined by Gruninger and Fox in 1995 has been reused through most of the methodologies listed here, and is still used in today's development. From methodology, we can reuse the idea of intermediate representation, and it was the first methodology to identify the activities and the organization regarding development, support, or management. From the Guide 101 for building your first ontology, defined by in Stanford, we can still reuse best practices and how to address common problems. It should be mentioned that this methodology or guide is oriented to frames, but it is still applicable to all ontologies. Diligent in 2004 was the first methodology considering local adaptation by different teams of a common ontology in a way to build ontology following a collaborative process. Finally, Neon in 2010 defined 9 scenarios for building ontologies, provided activities templates and guidelines for some of the activities involved in such scenarios. In the rest of this session, we are going to enter in details about the LOT methodology that has been built considering the good practices and core activities already considered in the previous methodologies. However, it goes towards a lightweight and agile processes that are inspired from software development practices, also trying to give tool support to couple software and ontology development, so that considering the ontology a first-class citizen in any software development. The LOT methodology, or link open term methodology, is structured as shown in the slide. There are 4 main activities that will be detailed afterwards. As in the traditional methodologies, it starts with the ontology requirement specification, from where we get the functional and non-functional requirements for building our ontology. During the ontology implementation, we will get the ontology code, and after that, we will go through the ontology publication activity. This activity is new, as in most of the existing methodologies, this activity was not considered, that is, publishing the ontology online following the W3C best practices. Also, there is an ontology maintenance activity at the end of the workflow that can trigger changes in any of the previous big main activities. In the slide, you have the reference to the online documentation about the methodology. Let's get into the details about the ontology requirements specification activity. In this, the goal of this activity is to have a list of requirements that the ontology should fulfill. For doing so, the ontology developers, experts, and potentially users will have meetings to understand which are the needs for the ontology and write down them using spreadsheets that could be online or local ones, or other type of test documents. For having an idea of some example of how to write ontology requirements, the Coral Corpus provides examples for 12 ontologies online. One of the sub-activities that can be carried out is the analysis of use cases or specification of use cases. For example, in the Salesforce City ontology, the use case e-health and smart parking was identified. In this use case, it was put in context how the SRF4 city ontology will be needed to define or to model the information about wearables, sensors, and monitoring of elderly people. Another way of extracting the requirements might be the identification of data exchange, for example, APIs, data structures, or services. In this case, we are seeing an example from the Web of Things ontology in which a JSON payload is analyzed to see which terms should appear in the ontology. With this input, the ontology development team, together with the expert, write down the purpose and scope of the ontology. After that, the functional ontology requirements should be proposed and completed. In the first step, there is a first round of functional ontology requirements. For this step, we can use the technique of the competency questions as seen before, or just write the requirements as natural language statements, as we are seeing in the slide for the SRF4 city ontology. In this case, these are requirements for the organization category. For example, a public organization is a type of organization. The main idea is to have a first version of the ontology requirements that can be reviewed by the users and the domain experts, so that at the end we will have a list of reviewed functional ontology requirements verified. Once this step is done, we can get started writing the ontology requirement specification document that can follow the template that is shown in the screen. In this case, the purpose and the scope will come from the second activity. Optionally, we could fill in the implementation language, that in our case will be OWL, and optionally also we can include the intended end users of the ontology. This template has been adapted from the NEON methodology, differentiated with fields are optional and which are mandatory. The intended uses of the ontology should be included, as well as the ontology requirements. This section about ontology requirements is where we'll guide the implementation of the ontology. As example of non-functional requirement, we can have information as standards that should be reused, or languages in which the documentation should be provided, for example, English, Spanish, or Italian. The difference with the field D, functional requirements, is that these functional requirements are more related to the ontology content, that is, which classes and relations and actions will be included in the ontology code. For this field, we can use the tables of requirements written as competency questions or as sentences. It should be mentioned that the intermediate tables from methodology will be also useful to be included in this field. Optionally, from these functional requirements, we can generate a pre-glossary of terms, that is, identify the concepts and relations and individuals, getting that information from the competency questions or the sentences. Once we have the ontology requirements specification document, we can start with the actual implementation. As you can see, the activity normally starts with ontology conceptualization before going through the ontology encoding, and optionally we can go through an activity of ontology reuse. During the ontology conceptualization, the idea is to convert the ontology requirements into a more structured or formalized model, but not yet implemented into the ontology implementation language. That is, we could use a formal language like any logic or diagrams, as you see in the slide. One example of how we build this diagram is from the requirement in the slide. A public organization is a type of organization. We can observe here that public organization is a concept and organization is another concept. Then such concepts should appear in the ontology. Actually, they are here, public organization and organization. And we also said that there is a relation of type of between them. As they are concepts, we translate this type of relation as a subclass of, so that this requirement leads to this subpart of the model. We will do the same for all the concepts and all the properties that appear between the concepts. For doing so, we could use pen and paper. We can write in paper physically, or we can use blackboards that could be also physical, or online blackboards or whiteboards. We can also use drawing tools as diagram.net or others, so that we can also generate these diagrams in a collaborative way. In addition, by using the chalk.linkdata.es notation, we can use also the chalk service to transform these diagrams to a first version of OWL code. Once we have the diagrams and additional actions that we might include in the diagrams or in other documents, we are ready to actually implement ontology, that is, transforming this conceptualization into the OWL code. For doing so, we normally use ontology editors as, for example, Protégé or Template Composer or others. It could be also a possibility to have some Adobe coding or Adobe scripting to generate this OWL code. And in some cases, for example, for the transformation of thesauries, we can use tools as OpenRefine, which has an extension for RDF. We can also use, as mentioned before, the chalk notation and an ontology editor in combination. So once we have the conceptualization, we will go through the ontology editor or other system as mentioned, and in case we are using Protégé, we will be editing each class property and data type property in the user interface, as well as adding as many annotations as needed, both for the ontology and for the terms that we are defining. Then we will export that ontology and the system will generate the OWL code. In this case, in the slide, we are showing turtle serialization of the Sareb for City ontology. We can manage all the resources being generated through the ontology development project by using support systems as Git for control versioning and also for collaborative edition. As it has already anticipated in the conceptualization, this model shows how some ontologies are being reused. In particular, this model represents the Sareb for City ontology. But you are seeing that in this model, the Sareb ontology is being reused, as well as other existing ontologies as GeoSparkle or the OWL type, among others. For carrying out the ontology reuse activity, there are some ontology registries where we can find ontologies. For example, the Sareb portal at sareb.etsy.org, where you can find the Sareb and all the extensions. But there are also general purpose registries like the link open vocabularies. Also, there are specific domain registries as Bioportal, AgroPortal, Log4IoT, and many others. And also we can find ontologies using other web engines. For more information about how to reuse ontologies, there is another session about reusing Sareb as part of this tutorial. Finally, once we have the ontology encoding, that is the implementation, both with the ontology we are developing and the ones that we are reusing, we should go through the ontology evaluation activity. For this activity, several tools are available. For example, one might want to check the ontology consistency, for what we can reuse existing reasoners. In addition, we can use systems like OOPS, available at oops.linkdata.es, in order to find common pitfalls or common errors. So it is possible to use this system online and also integrate it into Ontology. That is a system that runs on top of the GitHub, so that orchestrates different ontology activities. OOPS detects 33 pitfalls, and it can be used through a web user interface or a web service. If we go through the web user interface, we can enter the ontology URI or paste the OWL ontology code. After running the system, we will get a list of results, that is how many pitfalls has been found, including the name of the pitfall and a small description of it. It also shows which ontology elements are affected by the pitfall. For example, in this case, there is a property has part and a property is part of, and they are not defined as inverse. So the pitfalls say they could be inverse of each other. For each pitfall, it is also shown how many times it appears and how important it is, whether it is minor, whether it is important, or whether it is critical. When it is critical, that means that might have some impact in reasoning. When using the web service, one could retrieve the output in RDF or in XML. Another system for evaluating ontologies is Themis, available as themis.linkdata.es. It is also available as a REST API. Themis is a system to execute tests to verify an ontology, and it is based on a control testing language. For using Themis, one should upload the ontology either by an URI or by file input, and also they should input the test either by URI, a file, or writing the test through the interface. There are 4 possible results of the execution step for each test and each ontology. For example, it could be passed if the ontology passes all preconditions and the result of the assertion that are expected. Undefined terms if the ontology does not pass the preconditions. Absent relation if the ontology passes the preconditions and the result of the assertion are not expected ones, but there are no conflict in the ontologies. And conflict if the ontology passes the preconditions and the result of the assertions are not expected ones, and the addition of the actions related to the test expression leads to a conflict in the ontology. Also, the results can be exported in RDF. Implemented and evaluated our ontology, we are ready to publish that release or the final ontology. For doing so, we will first propose a release candidate. We should then generate ontology documentation. For generating HTML documentation, we can use Widocom that generate the HTML from the OWL code and also allows for multilingual configuration. Also, we should be generating diagrams and examples. If we have done the diagrams in the conceptualization, they can be easily reused in this step. Some tools, as mentioned before, are diagrams.net, IED editor, or other applications. Finally, for the online publication, we should decide whether we are going to publish the ontology in our own service, choosing our own URI scheme and pattern, or whether we are going to use persistent URI services as PUR or W3IG. The publication should be done using content negotiation. It is also advisable to register our ontology in existing registries or repositories of ontologies, for example, love.linkdata.es or those available in the domain of our ontology. Finally, for the maintenance activity, we recommend to use Git services that integrates issue trackers so that we can identify new needs or bugs and improvements. And it will have an impact in some of the previous activities. This has been all from my side, and I wanted to wrap up this presentation with this image of the expanded ontology development methodology. In this slide, you can see all the sub-activities that we have been mentioning before, the connection between the activities identified by the blue arrows, and also the connection with the output of each activity. Hope this has been useful for you, and see you in the next sessions.